Ever felt that nagging doubt after writing a SQL query, wondering if there was a faster, cleaner way to get the exact same results? Turns out, there often are 5, 6, or even more. Writing efficient SQL isn't just about pulling data. It's about building scalable applications, keeping your users happy, and let's be real, saving your company a boatload on server costs and developer headaches. Trust me, I've been there, debugging a query that took literally minutes to run. By the end of this video, you'll understand 5 distinct ways to tackle a common SQL problem, and you'll walk away knowing precisely when to use each, and which one is almost always the performance king. The problem: employees above department average. Okay, so here's the deal. We want to find all employees who earn more than the average salary within their own department. This isn't just a simple aggregate. It's a classic scenario that forces you to think beyond basic joins. This kind of query is a rite of passage for many developers. It really pushes you to understand how SQL can correlate data across different levels of aggregation. It's not just about filtering rows. It's about filtering based on a group's characteristic. Method 1. The correlated subquery, the classic and often slow approach. First up, the correlated subquery. This is often the first solution many developers reach for because it's conceptually straightforward. For each employee, go figure out their department's average, then compare. It reads almost like plain English. Here's the hot take. While intuitive, this method can absolutely tank your performance on large data sets. Why? Because that inner subquery runs for every single row of the outer query. Imagine iterating over thousands or millions of employees. It's an N+1 problem in SQL form. Method 2. Derived tables, the subquery and from approach. Okay, so if correlated subqueries are slow, how do we fix it? Enter the derived table. Instead of calculating the average salary for each employee, we calculate all department averages once, then join that result back to our employees. It's like pre-calculating your ingredients before you start cooking. Honestly, this is a huge step up. The database only needs to compute a VEG salary, grouped by department_ID one time, and then it's just a regular join operation. This approach dramatically reduces the number of computations, especially for large data sets. It's usually my go-to if CTEs aren't available or if I need to chain multiple subqueries. Method 3. CTEs, Common Table Expressions, the modern classic. Now, let's talk about CTEs, or Common Table Expressions. If you're working with modern SQL, this should be your bread and butter. CTEs offer the same performance benefits as derived tables, but with significantly improved readability and organization. Think of them as temporary, named result sets that you can reference within a single query. We've seen the slow, the steady, and the elegant. But here's where it gets really interesting: understanding why these differences exist and how to pick the perfect tool for your next query. Plot twist. Under the hood, many database optimizers treat CTEs very similarly to derived tables. So, performance-wise, they're often neck and neck. The real win here is maintainability. When you have multi-step transformations, chaining CTEs makes your logic incredibly clear, almost like writing functions. I genuinely think this is the most underrated aspect of CTEs. Method 4. Window functions, the true powerhouse. Alright, buckle up, because window functions are where SQL really starts to flex its muscles. For our problem, finding the average salary per department and comparing it to each employee's salary, window functions are arguably the most elegant and often the most performant solution. What's wild about this is that the AVG e.salary over partitioned by e.department_ID part calculates the average for each department without collapsing the rows. You get the aggregate value alongside each individual employee's data, all in one pass. This is incredibly efficient, as the database typically performs this calculation in a single scan of the data after the join. Some devs swear by window functions for anything involving group-level calculations that need to be applied back to individual rows, and honestly, I agree. Method 5. Temporary tables, structure for complex workflows. Finally, let's look at temporary tables. While not a query style in the same vein as the others, they represent a distinct strategy for breaking down complex problems. For our scenario, you'd create a temporary table to store department averages, then query against it. The main benefit here is for extremely complex, multi-stage data transformations where a single giant query becomes unmanageable. You can build up intermediate results step by step, making debugging easier. However, there's overhead: creating, populating, and dropping a table. For our simple problem, it's overkill and often slower than CTEs or window functions due to I/O operations. Unpopular opinion: don't reach for temp tables unless your query is truly sprawling and unreadable otherwise. The verdict: which way is best? Real talk, there's no single best way for every query, but for our specific problem, the window function approach usually wins on both elegance and performance. It's concise, highly optimized by most modern database engines, and keeps your logic in a single, readable statement. If window functions feel a bit too advanced for your current project or database version, CTEs are your next best bet. They offer excellent readability and similar performance to derived tables, but are much easier to manage. Derived tables are solid, especially if you're on an older SQL version. And the correlated subquery? Avoid it for performance-critical tasks, unless you're dealing with tiny datasets where readability truly trumps all else. Let's recap. Correlated subqueries are intuitive but often inefficient due to repeated execution. Derived tables and CTEs offer better performance by pre-calculating aggregates once, with CTEs leading in readability. Window functions are powerful, highly optimized, and often the most elegant solution for complex group-based calculations. Temporary tables are useful for breaking down extremely complex, multi-stage workflows, but come with I/O overhead. The key takeaways: prioritize readability with CTEs for most complex queries. Leverage window functions for superior performance on analytical and group-wise problems. Benchmark your queries. Actual performance can vary significantly between database systems and data volumes. Always consider your database's version and capabilities. Some features might not be available. If this deep dive into SQL query optimization helped you see things in a new light, consider giving this video a thumbs up and dropping a comment with your favorite way to write complex SQL. Your insights help us all learn and grow. And if you're hungry for more, next, watch our video on understanding SQL indexes to supercharge your database performance even further.